Good afternoon, and welcome to Talks at Google in Cambridge, Mass. Today it's my great pleasure to introduce Bernard Carlson. Dr. Carlson is here to discuss his acclaimed biography, Tesla, Inventor of the Electrical Age. Tesla certainly needs no introduction here. Bernie Carlson might, but rest assured he is also a major dude. Here are a few highlights from his extensive CV. He is the Joseph L. Vaughan Professor of Humanities and Chair of the Department of Engineering and Society at the University of Virginia, where he also holds a joint appointment with the History Department. As an historian of technology, Bernie has written widely on invention and entrepreneurship, as well as on the role of technology in the rise and fall of civilizations. His publications include Innovation as a Social Process, Elihu Thomson and the Rise of General Electric, 1870 to 1900, and Technology in World History in 7 volumes. In 2008, the latter was awarded the Sally Hacker Prize, great name, from the Society for the History of Technology as the best book aimed at a broad audience. And among many other accomplishments, he recently completed a 5-year term as Executive Secretary of the Society for the History of Technology. Please join me in welcoming Bernie Carlson.
Thanks. Well, thanks for coming out, and thank you, Jonathan, for that kind invitation. It's a great pleasure to be back in Massachusetts. While I now live in Virginia, I spent much of my youth and education up here. I studied at Holy Cross College, about 40 miles away in Worcester. Did my postdoc at the Harvard Business School, yes, that school, the business school across the river, and more importantly, just around the corner from here. I did my sabbatical in 1994 and lived at Eastgate. Practically, you can see it right out the window. So it's a great pleasure to be back here and to talk to you about Nikola Tesla. And part of my purpose today is, as I was saying to Jonathan, is to insert ideas about Tesla into the conversations, into the thinking, into the work that you have to do every day here at Google. I'm a historian of technology by criminal trade, but I spend my life in engineering schools and run the largest non-technical department in the engineering school, as I like to say, Mr. Jefferson's Vo-Tech and University. And I'm really interested in that interplay between technology and the rest of society. That's why it's called the Department of Engineering and Society. But I'm really interested in how we make the next generation of outstanding innovators. How do we train people to do the magic that is so important for our society and for the global economy? So Tesla is an ideal subject for that because he's not somebody who's just a mythic character. He's an individual who has, as you'll see today, important things to tell us about how technology gets done, whether we're talking in the 19th century or we're talking in the 21st century. But let's just talk for a moment about Tesla in popular culture. You can summarize where he sits in popular culture. He is indeed a figure in popular video games like The Dark Void, but he has had a whole different set of roles, a whole range of roles in popular culture. Some people say he's a genius. He is the Leonardo of the 20th century who invented everything that has to do with electricity and electronics. There are other people that sort of say, oh, he's not a genius. He's really kind of a lunatic. He's a nutcase. He had all sorts of wonderful dreams, but he never finished 3/4 of them. And in fact, in his dying days in the late 1930s and 1940s, he spent most of the time in the park behind the New York Public Library feeding pigeons. Or, if you don't like either of those two explanations, he's a space alien who indeed came to Earth from Venus on the wings of a giant dove to save mankind from the horrors of atomic Armageddon. Needless to say, this is a book that was published in 1951, and I always trust all books that are published and printed in green ink. And indeed, the book where that idea comes from is titled On the Wings of a Dove, published by Margaret Storm, and the book is printed in green ink. I'm not sure how many books are printed in green ink, but this one, when I saw that, sort of said, ooh, that's a really authoritative source. Okay, so that's Tesla in the popular culture. My argument for you today is Tesla is valuable if we're standing in engineering schools where I work, or standing in business schools, or operating in companies today. Why? He invented two disruptive technologies. One is the alternating current motor that he worked on in the 1880s, which completely revolutionized how we consume energy in our lives today all over the world. If that was not enough, for a second act in the 1890s, he worked on wireless transmission of power. He had a vision that radio waves or electromagnetic waves should be used not just for broadcasting or for communication purposes, but should be used to actually transmit power from point A to point B. In a certain sense, and this is why I let the publisher title the book, Tesla, Inventor of the Electrical Age, he is one of the few guys who contributed to both electric power and to electronic communications. So Tesla is an interesting individual because he had one great success and he had one, well, unsuccess, shall we say. So he allows us to look at what makes for big breakthrough technologies and what doesn't make for great breakthrough technology, because he has a success and a failure. And we can do so through Tesla's career without resorting to the standard explanations, which is we often sort of say, oh, breakthrough technologies, amazing things. It's genius. You know, you gotta be Steve Jobs. Or they say, it's just dumb bunny luck. You gotta be Steve Jobs, okay? And I wanna get away from, with my students, with you, thinking about breakthrough technologies as a result of genius or luck. To underline where I'm going with this is some of you are probably familiar with how economists look at technological change over the long haul. And they often, based on work done by a Russian economist in the 1920s, talk about Kondratieff curves, which is there's an ebb and flow over a long period of time from the 1700s to the 21st century, and there are waves of technological change. Okay, now most people sort of say, they look at this and they say, oh, well, if it was 1880, it's time for that wave that's electricity and chemistry. If it's 1910, it's time for the automobile. And they don't really stop and think that the arrival of those different waves and the shape of those waves and the timing of those waves is so dependent on individuals. Submitted for your consideration. What's behind that curve is not just big structural changes in the economy or the availability of technology, but individuals who shape the technology to match up to the social and cultural opportunities of the time. Tesla is one of those guys. George Westinghouse is another. Thomas Edison is a third. And you could indeed argue about the automobile. It's somebody like Henry Ford or Alfred P. Sloan. So I'm after big fish here in terms of talking about Tesla and disruptive innovation. Now, I spent 15 years working on Tesla. And you might sort of say, oh my God, I heard the laugh in the back of the room. Oh, he spent 15 years on this guy. Why? Because he was an intriguing character to deal with. I had to figure out how to weave together several different social roles that are not normally juxtaposed. First off, he is an inventor. He is somebody who worked in the technological realm and did successful cutting-edge technology. At the same time, he functioned a little bit more like an artist than a scientist. A lot of people sort of say, oh, Tesla, inventor, and then scientist. And I'm like, slow down there, dude. I'm not sure about this science thing. He is definitely like an artist. And in particular, because he's more intuitive. If you ask Tesla, or you went to his laboratory in the 1890s and you watched him work, what you would see is you wouldn't see a lot of tinkering and working with wires and messing around with stuff, which is what you would see if you went to Edison's laboratory in the same time period. Edison was a tinkering kind of guy. Tesla, on contrast, was what you might call a theoretical inventor. It all happened up here. And it all turned much more, less on that hands-on experimentation than on intuition, on having an idea and then imposing it on reality. Okay? And in that sense, he's more like an artist and less like a scientist. Now, lots of people would sort of say, oh, Tesla, world's worst businessman. Submit it for your consideration. One of the things I want to convince you in the next few minutes is that Tesla was actually a pretty smart entrepreneur, that he had a business strategy for making money. We don't appreciate it necessarily because it doesn't conform to what we think are the standard ways that we believe that inventors in the 19th century operated. So Tesla kept me busy for 15 years because I had to weave together inventor, artist, entrepreneur. Now, to pull those things together, I developed a set of themes. And indeed, I actually thought that the book ought to be called Ideal and Illusion. And my publisher said, oh, don't do that, because I really think it's some sort of theological tract and nobody will buy any copies. And there you go. So I said, okay. But at the heart of the book are two dueling ideas about Tesla's style as an inventor. And I think inventors, like artists, have a style. They have a way of doing things. They have a way of making sense of the world, of making meaning. Tesla's was a tension between ideal and illusion. Tesla believed, based on his religious background, his father was a priest in the Serbian Orthodox Church, that behind everything in the world, whether it was made by God, i.e. animals and plants and minerals, or made by man, there was a fundamental principle that was behind it. And that the job of an inventor was to find the perfect way to make an invention. And if you could glean, you could discern that perfect idea, then you would have a great invention. Now, this is very Platonic, as in the sense of what Plato had to say in his dialogues, particularly the analogy of the cave. And you may remember that only the philosopher king, or the philosopher, can actually see the truth. Everybody else is trapped down in the cave looking at flickering lights and debating the nature of those flickering lights that they see on the walls of the caves. Mere mortals are stuck trying to deal with approximations of the truth, illusions. Tesla believed that you had to develop illusions, stories, values, metaphors that allowed people to begin to see where the ideal was. And he was willing to put a lot of effort into capturing people's imagination. And one of the things that's really important about him for the young people, the undergraduate engineers I teach, is to remind them that it's not just about getting the code right, it's about the story that you tell about your software that engages the imagination of people. So where did Tesla develop this mix of ideal and illusion? Tesla was born in 1856 to a Serbian family who was living in what is today Croatia, but back then was the Austrian Empire. It was a section of the empire, the Austrian Empire, that was kind of a military zone, a buffer zone between the Austrian heartland and the Ottoman or Turkish Empire. And the Austrians, to manage that zone, mixed Muslims and Christians, i.e. Catholics, and Serbian Orthodox people, and bundled them all together so that nobody really controlled the entire area. And sadly, the history of Yugoslavia is a result of that mixing up of all of these people. And indeed, where Tesla was born is still a very contested, complicated place. I've not been to his birthplace, have no particular desire to go there, okay? Now, as a child, Tesla had it, as I said in the book, he had an interesting childhood, way more interesting than certainly I had, and I'm not sure that I want my daughters to ever have had. Okay, he had severe vision. He had a problem with his imagination and with nightmares. So if you said to Tesla, juicy apple, he'd see out there in sort of a three-dimensional space there, he'd see this beautiful red apple, and it'd be all juicy, and he'd start salivating, he'd say, apple, apple, apple. I mean, he's a little kid. And he could not get rid of that vision of that juicy apple. It would haunt him all through the day, once you started down this path with that particular image, all through the night, okay? And needless to say, this was a troubling thing when you were a little kid. About 10, 11, 12, somewhere in that zone, pre-adolescence, he reads a novel. And the novel basically talks about an individual who's kind of a good-for-nothing prince, but proves himself to his monarch. It's set in the Austrian Empire, and proves himself to his king and becomes a hero because he develops discipline, he develops willpower. And young Tesla decided that he was going to develop willpower. And the willpower that he needed to develop was all around getting control of these images. So instead of just being overwhelmed by the images, he imposed an order on them. And he began to go in his imagination on fabulous journeys. He developed entire cities. He developed imaginary friends, indeed imaginary societies. And to go from one place to another in his imaginary world, he flew. Well, along the way, he decides that, there shouldn't only be flying in his imaginary world, there should be flying in his real world. So he decided when he was about 12 or 13 to build for himself a flying machine, which probably consisted of some sort of pump or machine on his back, like a backpack with a helicopter up there. That's about as much as I know. And it was based on some vacuum pump principle. And he built a prototype, and lo and behold, the prototype moved a little bit. And Tesla was elated because it confirmed that what he could imagine in his mind could happen out there in the real world. And that set him on the path to being an inventor. If I can imagine it up here and it happens in the real world, then there's some rationality or meaning to all of these things that I can imagine. It sets Tesla up, however, in a complicated, tricky way, because he's always looking for the upside of his discoveries. He's always looking, as Karl Popper, the famous philosopher, would say, for confirmatory evidence. But more on that in a little bit. Tesla goes to engineering school, kind of violates the family norms. Both his father and all of his uncles were priests in the Serbian Orthodox Church. He didn't want to go into the church. He convinced his father that he ought to go study engineering, and he studied engineering in Graz, Austria. There, in a story that's interesting, but I'm going to just kind of pass over, he decides, after watching a demonstration in physics lab, in his physics lecture, not in the lab, that he should invent a better electric motor, a motor that is sparkless. To develop that idea, he thinks that it's going to use a rotating magnetic field. Explain that in a moment. To get more information about how all sorts of electric motors and electric machines work, he works for several Edison companies in different cities. First in Budapest, where he helps install a telephone exchange. Then he goes to Paris, helps install electric lights. He does such a good job that he's transferred to the New York offices of the Edison company. But that really, if you will, is his graduate school in electrical engineering. That's where he really learns the technical business. He leaves the Edison organization, and after a number of adventures, he teams up with a pair of individuals, Charles Peck and Alfred Brown, who will allow him to develop his alternating current motor. Now, there are two physics lessons in this particular class. I probably don't need to apologize for this audience, but sometimes I often have to say, there's going to be a little science here, and, just bear with the historian teaching a little bit of science. Okay, in 1887, Tesla perfects an alternating current motor, okay? Now, all motors, whether they be DC or they be AC, work on the principle that there are two pairs of magnets in the motor, okay? There's a stationary pair called the stator, and there's a moving pair called the rotor, okay? As long as those two pairs of motors, the stator and the rotor, have different poles, that is to say a north pole, where they have the same poles, the north pole and a north pole meet, they push away from each other, okay? Because if it was a north-south pole, they'd be attracted to each other. So as long at any given moment, as you have one set of magnets moving around, that is to say rotating, those always have a north pole. When they meet another north pole, then they'll push away from each other. So Tesla's big idea was, if we look at this diagram from his 1887 patent, is the donut is the stator, and it has 4 coils, okay, 4 electromagnets. And this rectangle that you see in the middle is the rotor. So every time this piece of the rotor gets up there, it has to have a north pole, so it's repelled by the stator. Now, before Tesla, everybody, who was in the electrical business, said the part of the motor where you change the magnetic field is the rotor, okay? In other words, you change the magnetic field in this, and you leave the magnetic field in the stator stationary. Tesla said, no, 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 no. I'm going to do this entirely backwards to everybody else. I'm going to be a maverick. We're going to induce a magnetic field in the rotor, and we're going to have a rotating magnetic field in the stator. Okay? So the rotating magnetic field goes around and around in the donut. Why? Through the magic of alternating current, which I am not going to explain to you here. If you feed 2 alternating currents into the donut, into those 4 coils, and if the 2 alternating currents coming off of the generator, this is the generator over here, are 90 degrees out of phase, you can create a rotating magnetic field. In other words, if we start here at noon, this is going to be north, and then the North Pole is going to go here, the North Pole is going to go here, the North Pole is going to go here, and it's going to go round and round and round, and it's going to induce a opposite magnetic and electric field in the rotor. Okay, science lesson number 1 is now concluded. Okay, this was an amazing thing. It allowed for Tesla to patent and develop the first practical alternating current motor, which allowed electricity for the first time not just to be used for lighting, that's what Edison developed, but indeed be used for all sorts of power applications: elevators, fans, machine tools, moving assembly lines. When Tesla develops this configuration of the motor in 1887, it essentially looks like this, but instead of that rectangle there, what he did to basically get proof of concept is he took one of those shoe polish tins, the Kiwi shoe polish tins, you all know it, it's kind of like this, and he had no shoe polish in it, and he basically in the middle of it put a thumbtack so it was on a pivot, and he dropped that in the middle of the donut, and the whole tin can went whee, and Tesla went eureka. So he brings in one of his 2 backers, Alfred Brown, who's a little more technically minded than the lawyer Charles Peck, and he shows to Brown that the tin can is spinning around in this coil. And I have this vision of Brown kind of peeking into the motor, looking into the donut, and seeing this tin can go spinning around, and then looking at Tesla going, "You brought me over here to show me a spinning tin can. Isn't that special?" And Brown basically went back to Peck and said, "I don't know, this guy's not really getting with the program. I'm not sure whether it's worth all the money we're spending on him." So Tesla realizes that he's got to come up with the right illusion for his technical backers, for Peck and Brown. And so he waits a couple days, and he goes back to their offices, which are around the corner. All of this is taking place in downtown Manhattan, in and around where the World Trade Center was, right around Ground Zero. And he walks into Peck and Brown's office, and he says to Peck and Brown, "So, you know how Christopher Columbus got the money for the Nina, the Pinta, and the Santa Maria?" And Peck and Brown go, yeah. They got it from Queen Isabella, and Queen Isabella hawked her jewels. And Tesla says, but what did Columbus do to convince Queen Isabella? And as the legend goes, Columbus was in the court of Queen Isabella and basically was trying to convince all of the experts, all the scholastics that were around the court, that indeed the world was round. And they were arguing with him, and they were going back and forth. And finally, I'm from New Jersey, I apologize, Columbus, who was Genoese, who probably did this, he did it up to here. And he said to the scholastics, this is Columbus speaking, he says, "Can you make an egg stand on end?" And the scholastics went, "Oh, I don't know. They're like promotion and tenure committees in engineering schools, but that's an aside. Terribly unfair to my colleagues, but I apologize. And but they say, "Oh, we can't do that." And Columbus says, "Bring me the egg." And I imagine this egg comes out, with a little flunky on a purple, like a nice little pillow, and there's the egg. Columbus says, "Bring me the spoon." And he grabs the egg, takes the spoon, whacks off the bottom of the egg, stands the egg up. And the scholastics are like, "Whoa, whoa, 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 whoa." And Queen Isabella says, "I like that guy. I'm going to give him money." So Tesla repeats this whole story to Peck and Brown and says, "If I can make the egg stand on end and go one step further and make the egg spin, will you give them the money to patent this thing? And they say, okay. So the next day, a couple days later, and only in New York, Tesla runs home, and on the way home finds where he can buy a copper egg. Okay, must have been about the size of an ostrich egg. And he basically puts the egg on top, as you can see in the picture, of the donut coil. Peck and Brown come in and they say, okay. Tesla turns on the electric current. The rotating magnetic field is created in the donut, and the egg starts off on its side and starts spinning, and spins fast enough that it comes up and winds up spinning around its vertical axis like that. Peck and Brown look at each other and say, he's our guy. We're going to spend the money. We're going to get this puppy patented. And as a result, Peck and Brown put together a set of patents, and Tesla becomes famous. Now, Peck and Brown taught Tesla an important lesson. They said, look, the way we're going to make money is we're going to patent, we're going to promote, we're going to sell. Okay, so first, we're going to get the very best patent lawyer in town, and he's going to get you outstanding patents for this design, okay? A mix of specific patents and system patents. Next, they said, you're going to do a series of lectures, you're going to do serious newspaper interviews, we're going to get everybody excited. We're going to have them go, oh my God, this is the greatest thing since sliced bread. And then, when the hype peaks, we're going to sell to the highest bidder. In this case, it was George Westinghouse, and Tesla basically walked away with the cash. Okay, this is a strategy that's very different than what we attribute to most inventors. Most inventors, like Edison, we assume made their money because they actually integrated forward and decided that they had to manufacture their inventions. If you look at the self-help literature in the 19th century, essentially the self-help literature says manufacturing is for suckers. What you want to do is get control of your idea, sell it to somebody who actually has the industrial capability to manufacture your invention. You don't want to get into manufacturing if you can humanly help it. That's what Tesla did, okay? So Tesla goes to Westinghouse, spends about 9 months at Westinghouse working on the routine engineering problems, and basically says, this isn't for me. So what do you do? Okay, there's no Disneyland, so what do you do? Well, if you're Tesla, you go in 1889 to the Paris World's Fair, which is indeed the World's Fair where the Eiffel Tower is unveiled. And there he, depending on how you want to think about it, he drinks absinthe or he drinks coffee with graduate students in physics and in electrical engineering. He meets one who studied with Poincaré, got his PhD with Poincaré in Paris, and is on his way to study with this guy Heinrich Hertz in Germany. And Tesla says to the graduate students, so what are you going to work with when you get to Hertz? And Hertz, the student says, I'm going to work with Hertz because Hertz has figured out that there are indeed electromagnetic waves that are invisible. James Clerk Maxwell, in the late 1860s, does for electricity and magnetism and light what Newton did for mechanics. That is to say, he developed a series of laws, a set of principles that organized the whole darn thing. Maxwell says that if you look at my equations, they predict that there are waves that are not visible to the human eye. And everybody says, well, that's nice. So where are they? Hertz, probably the best experimentalist of the late 19th century, student of Helmholtz, basically says at his laboratory in the University of Bonn, he says, right, bring on the toughest problem. And Hertz figures out how to detect those radio waves, those electromagnetic waves. And he does so using an apparatus that you see up there. And most of this apparatus, all this stuff up here, is a battery telegraph key and a Rumkoff coil, a double wound transformer with two windings on the same core. And down here, this thing that looks like an earring is the receiver. And Hertz walked around his laboratory with this ring, and he basically detected radio waves because whenever there was a spark here at H, there was a spark here at L in the receiver, okay? So Tesla finds out about all of this. Now, you're a good inventor. What do you do when you see a scientific discovery like this? Well, you want to soup it up. And that's exactly what Tesla did. Is the Tesla coil that we all know and love. And depending on how I travel, I often bring for demonstrations like this a Tesla coil, but I wasn't sure whether I'd ever actually get it in the building. I probably could have gotten it in the building here today. But this is a Tesla coil down here, which is essentially a high frequency, high voltage transformer, all the parts of which are tuned to get maximum high voltage, high frequency out of it. And it's all based on souping up the Hertz apparatus. Okay, so what do you do with electromagnetic waves? Now notice, I'm calling them electromagnetic waves because radio is a term that only comes into use about 1903 or 1904. So if we're talking before that period, we got to talk about them either as Hertzian waves or E&M waves. Okay? Tesla says, hey, I'm a power guy. I made motors. I'm going to do something on the power side. I'm not really worried about this communication stuff. And everybody else in this time period that knew about Maxwell's work and Hertz's work was also interested in power applications. Tesla says, here's what we're going to do. If you have a Tesla coil and you have a Geissler tube near it, it instantaneously goes off. It starts lighting up all by its little self. Every time the Tesla coil discharges, you get a flash through the Geissler tube. Okay, and the Geissler tube is basically filled. It's a tube you basically take all the air out of it, and then you put a little bit of something like argon or neon gas inside it. So it's like a neon tube. So Tesla said, I'm going to make an entire wireless lighting system around that. And here he's demonstrating it in New York and at Columbia College in 1891. He's got two big zinc plates on either side. They're connected to a Tesla coil that's over here. He's about to take these tubes that are about like this long, and the lights are going to go out, and he's going to step between those two plates. The plates are charged, and he's going to start waving these giant tubes, and they're going to light up wirelessly. In other words, you're not going to need any of these annoying wires. You could have a wireless lighting system in your home. And Tesla's vision is you would have metallic wallpaper, and you would basically have your lights on stands, and you would just rotate the light so it was aligned with the electromagnetic field of the two plates, or the two sides of the two sides of your living room. So he thought it was a pretty good idea. He goes on ahead in the mid-1890s, he patents it, and he promotes his ideas through a series of lectures, private demonstrations. He invites people, good friends like Mark Twain, to come and play with the apparatus, and that indeed is Twain holding about a hula hoop-sized coil over a Tesla transformer, and there's a little light bulb right where his belly button is, and the electricity that is transmitted to the hula hoop that you can see causes that light bulb to basically illuminate. Okay, but he's got the right idea in the wrong moment. In the 1890s, there is a major recession following the panic of 1893. Nobody is able to raise money for any new high-tech ventures, and nobody comes forward to develop this idea. Tesla experiments with a couple of other ideas, with X-rays, with radio-controlled boats, but finally realizes that he's got to rethink wireless power. Okay, now, you've all seen pictures of radio waves or radio towers, and they show at the top that at the top of the radio tower there's these spheres of concentric spheres radiating out that show you that the energy comes off the top of a radio tower and it goes in all directions. And we really do mean in all directions. So it goes to the left, it goes to the right, it goes up, down, it goes up, it goes down, it goes to Mars, it goes to Jupiter, it goes everywhere. This annoyed the living daylights out of Tesla. He said, boys, girls, 99% of the energy goes off into space and only maybe 1% ever gets to your receiver. This is a bad idea. So Tesla said, no. What we're going to do is we're going to reconfigure our transmitter circuits so that we minimize the amount of energy that goes up to the antenna, and we maximize the energy that goes into the earth, the ground current. So what was Tesla thinking? Okay, on the top is how Marconi, Lodge, everybody else in electrical engineering in the 1890s thought about how radio worked, okay? So you got a transmitter. You pump all the energy up the antenna. It goes across through the ether, beep, 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 from the transmitter's antenna to the receiver, and is there converted into music, into voice, whatever, and both the receiver and the transmitter are grounded, so you have a complete circuit that runs like this. Thinking like a true maverick, Tesla said, everybody's got so hung up on the details. It actually works the other way. As my English wife would say, it's not clockwise, it's anti-clockwise, okay? What you want to do with the transmitter is you want to pump energy, oscillating electric currents, into the ground. The energy goes from the transmitter through the ground, beep, 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 to the ground connection underneath the receiver. The receiver processes it, either for voice or messages or for power applications. And you have some sort of circuit that is completed in the high atmosphere as far as Tesla was concerned. Okay. To prove this idea, he goes in 1899 to Colorado Springs. And while he's there, he becomes convinced that this whole thing is actually going to work. On the left-hand side, you see there his transmitter, okay, which consisted of a giant Tesla coil. The primary of the coil was basically at the top of this fence right here, and it constituted a circle that was almost 50 feet in diameter. The secondary of the Tesla coil was over here, and it basically generated energy that was pumped into the earth. Now, because you couldn't see anything when the energy was pumped into the earth, they adjusted the coils so that for the purposes of these publicity photographs, all the energy comes up, goes to the ball, and basically is the electromagnetic, the electrical voltages are so high that you ionize the air and you get these sparks across the way, and they're picked up by a coil that you can't see. It's just outside the frame of this picture. Now, Tesla thought that this would give people a good idea how much power is involved. By the way, Tesla tells us in his notebooks that this photograph here is a trick photograph. That is to say, it was made on a glass plate and was done with 2 exposures. The first exposure is before any of the electrical machinery was turned on, Tesla sits there and very calmly reads the book. You know, probably Maxwell's equations. Okay, then he gets out of the chair, and before they crank it up and have hundreds of thousands of volts going through the air, he's out of the way. So this is a trick photograph, but the point is he wanted to create the illusion of the power that was being moved or manipulated at Colorado Springs. Out in the pastures, out in the fields, right next to Colorado Springs, this was a typical sort of receiver. This is a great big coil, and you can see that energy is wirelessly transmitted, and it makes this little light bulb light up down there, okay? Curious thing about Colorado Springs is every time Tesla got evidence that confirmed that energy passed through the earth, he was happy. He never tried to torture test his experiments and to disconfirm his hypothesis. 1900, Tesla returns to New York City and announces to the world that he is going to transmit energy and messages across the Atlantic Ocean in 8 months' time. He basically publishes an article in the equivalent of today's New Yorker, the Century magazine, that explains that he has invented everything you ever need to know about energy and how it's going to change human civilization. He lives the life of a winner. He moves into the Waldorf Astoria Hotel. He wears the best clothes. He strides down Fifth Avenue like a peacock. He eats at dinner at the best restaurants. And to some extent, I would say as a biography, what's going on in his mind is the following. If you say all the right things, you do all the right things, you're interviewed, you're seen with all the right people, then everything will fall into place. If you get the illusion that you're a winner, then you will be a winner. The scheme works to a certain extent. In 1901, he secures from J.P. Morgan, the most powerful banker on Wall Street, a loan of $150,000. And to secure the loan, Tesla offers and signs off on giving Morgan 51% of the patent rights. Okay? Tesla fills in and says, I'll give you 51%. Morgan doesn't ask for this. Tesla decides to give it to him. Why? In part because he's hoping that Morgan will be the good business partner that Peck and Brown were a decade or so earlier. With that money, Tesla builds out on the North Shore of Long Island, about 60 miles from New York City, a new experimental station at Wardenclyffe. This building is still standing. This is the building that, if some of you know, that the Oatmeal did a Kickstarter campaign a few years back in 2012. This is the building that they rescued. This is the tower. And the important thing is, everybody gets all worked up about the tower. What's actually important is there was a 120-foot shaft, deep shaft underneath the tower, which is where Tesla anticipated he was going to pump the energy in, okay? And as he said, Tesla often said, in order to get a grip on the earth and shake it. So what happens? Everybody says that Tesla and Edison had a terrible rivalry. My friends, the rivalry that really counted was between Tesla and Marconi. Tesla thought Marconi was a Johnny-come-lately, good-for-nothing, low-life punk. Okay, and those are just the things I can repeat in a public audience. Marconi watches Tesla like a hawk. Marconi begins working on basically his idea for wireless telegraphy, sending dots and dashes using electromagnetic waves beginning in 1895. Marconi does it by first sending it a mile, 5 miles, 50 miles, eventually 100 miles. By 1901, Marconi realizes that if he's going to win, he's going to have to beat Tesla in getting a message across the Atlantic first. And in December of 1901, Marconi and his assistant George Kemp are sitting, freezing their butts off in St. John's, Newfoundland, and they hear faintly the Morse code signal for the letter S, which Marconi had arranged for his station on the other side of the Atlantic in Cornwall, England, to send at regular intervals. December 12th, they hear the signal. On December 14th, I think it's a Friday, December 12th is Friday, Sunday is hence the 14th. It's front page news in the New York Times. Pardon me, Marconi is regarded as the new inventor of radio. Tesla is a has-been. Now, you took $150,000 from the most powerful man on Wall Street. You promised to be the first to cross the Atlantic, and this Italian punk beat you to it. What are you going to say to J.P. Morgan? How are you going to deal with this? Most of us would probably run and hide behind the nearest thing we could find. Tesla had a unique mix of bravado and courage that fascinates me every time I tell this story. In February 1902, Tesla says, we're going to one-up Marconi. And he says, Mr. Morgan, don't worry about what Marconi is up to. The major opportunity is a world telegraphy system. Imagine, if you will, that outside every city is a transmission plant like Wardenclyffe. And at those plants, you send out, by wire or by other means, all of the telegrams that you need to send, all of the stock quotations, all of the telephone messages, all of the fax messages that you want to send, all of the electronic information. You tag it with different frequencies, and you pump it into the earth. Everybody around the world will have their own receiver in their pocket, no bigger than a pocket watch, and they will be able to receive the messages that are relevant to them. The whole earth is like a brain, as it were, and the capacity of this system is infinite. You see, Mr. Morgan, the revolutionary character of this idea, its civilizing potency, its tremendous money-making power. Tesla had a vision in 1902 of an information revolution. but not an information revolution that was business to business. That's what everybody else was talking about. This was going to be an information revolution about individual consumers, that everybody would benefit by having access to vast amounts of information. Now, Tesla did not have any idea about smartphones, about the World Wide Web, about search algorithms. He didn't understand that, but he had a vision that the 20th century, and indeed the 21st century, was going to be about information for everyone. Consider this slide, or this newspaper story that comes from 1904. There's his WARDENCLYFFE Tower. Now, the author is taking some liberties and showing that radio waves or signals are going from the tower, not through the earth, but to individuals. But look what's happening here. You could be out on a camping trip, and you could take your tent pole, hold it up, and get information. You could be out on your yacht. And this is middle class or upper middle class vision. You'd be out on your yacht, and you could get signals via your mast. Or my all-time favorite is the one in the middle. You could be a lady on vacation in the Berkshires, Saratoga, and you want to know the latest social news from New York City or Boston. You just hold up your parasol, and you can collect the information on some sort of receiver that you got in your pocket or your purse or somewhere else. Okay. Tesla saw a consumer revolution in 1902 for information. Now, Tesla fully understood that you weren't going to make money selling the information. The information was going to be for free. You folks in this room know all about dual-sided business models. You give away the information for free, and you collect the money somewhere else. Google does it through advertising. Morgan and Tesla thought that they would do it by basically selling the receivers, manufacturing and selling the receivers. Morgan, up to a point, agreed with all of this, and then something happened on Wall Street. A series of lowlives, particularly Lee DeForest and Abraham White, set up their own radio companies. And DeForest was the first guy to use the word radio. And they basically created companies, promised to build technological systems, and never delivered on the systems that they had. So it was a stock market scam. They'd sell the stock and then they'd run away with the money. Okay? This created a crisis on Wall Street, a small crisis, and Morgan and other financiers said, in Tesla's own words, that they would not touch wireless companies with a 20-foot pole, okay, that they were just bad news. Okay, and in 1903, Morgan pulls out of the deal that he has with Tesla. Tesla continues to look for other support, but we have to go back to that 51% deal. Okay? Tesla basically had given Morgan 51%. And Morgan said, you get money from anybody else, that's fine. Okay? But I still get 51% of the revenue. So other investors sort of look and say, why are we going to put in money if half the money or more than half the money is going to go to Morgan and he's a silent partner? We're not interested. Because he structured the deal the wrong way, Tesla was out of luck. Okay? In the meantime, the press, newspapers, technical journals, had celebrated Tesla as the second wizard, only second to maybe Edison, or equal to Edison, all through the 1890s, all through the early 1900s. Around 1904, 1905, the press flips and decides that he's a has-been. He's a visionary and a poet. In this time period, 1904, 1905, Tesla continues to fire off absolutely crazy letters to Morgan. Some of them are just so sycophantic, they just make your flesh crawl. They go, ooh, don't say that. And then there's others like, I can't believe you're not helping me. And Morgan just decides, I'm not going to deal with this guy. This guy's a nutcase. At the same time, Tesla's closest friend, Richmond Hobson, that he's really, really close to, decides, yes, he's going to marry a woman named Griselda, and Hobson wants to run for Congress, and so he needs to basically be an upstanding married guy, and so Hobson basically leaves Tesla, okay? And Tesla writes letters to friends that basically indicate that he's probably suffering from mental depression and nervous breakdown, and he signs him Nikola Busted. The last part of Tesla's life is fairly sad. He dies in 1943. And he works on a couple of things in the 1910s, such as a bladeless steam turbine and some other minor inventions. In the 1930s, he gets a certain amount of publicity in that he announces that he's developed a particle beam weapon that can protect America from long-range bombers. And that results in, shortly after his death, that the FBI spends a brief amount of time checking his papers, decides that there is really no particle beam weapon, but it sets up conspiracy fans unto this day that are convinced that there was a particle beam weapon. And in the 1950s, his papers go to the people of Yugoslavia as a gift from the US government. As I said in the beginning, Tesla, inventor, entrepreneur, artist. He was an inventor. One great success, one great vision. The alternating current motor, wireless power. In looking at these things, whatever made him a success also contributed to his problems with wireless power. The mix of ideal and illusion. He's an entrepreneur. I want you to walk away and sort of say, this is a guy who really understood the strategy of patenting, promoting, and selling. And where do we see this? We see this time and again when basically people do IPOs out in Silicon Valley. They get good intellectual property, they promote it, and they do the IPO and they sell it out. Okay? He's an artist, not a scientist. He's concerned about the meaning. What are people going to think about my inventions? How are they going to use it? And his inventions came back to those dreams from an inner ideal that he hoped to impose on the world. Very different sort of strategy than most engineers or other inventors use. Tesla was a visionary leader. We often say that necessity is the mother of invention. But I say to you, breakthrough technologies don't come with well-defined pre-existing needs. Okay, the connection between the design of the technology and its ultimate social or economic use is brokered, is shaped by inventors, by the ability for inventors or entrepreneurs to tell powerful stories that locate that device with a set of uses or wishes that individual consumers have. And that process is often complicated. And as Arthur C. Clarke said, any sufficiently advanced technology will appear as magic. Okay? That the connections that individuals like Tesla make are not always easy to discern. Let me stop at this slide. What's Tesla's legacy? If you look at a picture like this that shows electric lights on all over the world, probably 99%, if not 99.99% of all the energy that's used to power those electric lights is done by alternating current, is done by using multi-phase power, all of which Tesla invented. I appreciate your time. I suspect I've gone on a little bit longer, and I'd be happy to answer any questions that you might have, and thanks so much. Questions?
So why aren't we ever transmitting power through the ground? Was he just completely wrong about the ground part, or did we just get distracted and, you know?
Okay, so one version would sort of say that we didn't just get distracted, but it wasn't a good business proposition for fat cat capitalists like Morgan or Edison to basically get rid of the copper wired systems. Now, I don't buy the business explanation for this. And to explain what actually happened, and there are still people working on this. There are people, just bear with me here as I find the right slide. Let's be clear that wireless power works in certain ways. Okay, so for example, through the 1990s, the US Navy used extremely low frequency radio waves that could travel through what's called the Schumann cavity, which is the cavity that is between the ionosphere and deep into the Earth's crust. And the waves would bounce through that cavity, and you could be in radio contact with nuclear subs that were deep in the ocean, and you could send them a happy signal so that they could be in touch. Okay, and indeed, where I lived in northern Michigan, I taught for a few years at Michigan Tech, and about 100 miles to the west of Michigan, they built this huge 110-mile antenna array at Clam Lake, Wisconsin. And it indeed was the way that they kept in touch with, the Navy kept in touch with the subs. Okay, so you can send radio waves, you can send energy through the Earth, okay, and that's what this illustrates. A company that's actually got roots here in Cambridge and at MIT actually uses a wireless system, at least over short range, to, as you can see, charge up phones, cell phones that are parked on a little tray. And there's a coil, which is the transmitter in the tray, and then there's a coil that's in a substitute back on the phone that allows you to charge it up. The vision is that you'll be able to walk into your office or your home at some point, and you won't even have to take the phone out of your pocket or out of your purse. The phone will just sense that it's in an electromagnetic field, and it will charge itself. Okay, so over short distances, there's probably wireless power applications that we'll see more used more widely in our lifetime. Now, could you do this all over the world? All right, now, the answer, I think, is no. Okay, but remember, I'm a historian, I'm not an engineering guy. The problem is as I say, is the Earth like a water balloon or like an ocean? Tesla thought that the Earth was like a water balloon, okay, which it was filled with an incompressible fluid. And if you pumped, like he shows on the left-hand side, at a certain frequency, i.e. the resonant frequency of the Earth or the water balloon, eventually you'd reach the point where with each subsequent stroke of the little pump, you'd have water popping out of these one-way valves. Now, we're using a hydraulic analogy here. Tesla, of course, is talking about doing this with electrical energy. The problem is how does the Earth respond to that electrical energy? Is the Earth like an incompressible fluid, or is it like a compressible fluid? In other words, is the situation such that if you threw a rock into the ocean, the waves don't travel from where I grew up in New Jersey all the way to Spain. Eventually, through friction in the fluid, i.e. the ocean, the waves peter out. And that's how the Earth actually responds to electromagnetic waves. Okay, so that's my understanding. Now, you've hopped up in the middle of this, my good sir. You've got a great question for me.
Okay, so you studied Tesla. You must have come across this article, interview transcription from 1899 with John Smith.
Yes.
Okay, so it sounds to me like he really conflates electromagnetism and spirituality to an excess. He sounds like a nutcase to me. What would be your assessment of that?
Okay, so the musical composer Phil Klein, within the last 2 or 3 weeks, sent me this article. So I've only skimmed it, okay? And I am trying to figure out, but my gut reaction is this article is a hoax. Okay, I don't think it's the real deal. Okay, because I've spent 15 years, and I'm pretty sure I've seen most of the critical stuff on Tesla, and there's no provenance associated with this article. It's not like, oh, it came from the New York Times and it was published in such and such a date. Okay, but I have to say I haven't actually done all, as the lawyers would say, the due diligence on this. Now, there is a certain amount of interesting interweaving of different things. If you go back to that Century article that Tesla published in 1900 about the future of electrical energy and human civilization. And when I actually do this sort of the Smith article, if you will, the Smith interview is as I'm going to be looking at it in parallel with what Tesla says and how Tesla says things in the Century article. Okay, so I'm not convinced. Tesla had a big vision, but I'm not sure that I'm convinced that the Smith interview is the real deal. Sir, I got you warmed up.
Hi. Thanks. So Tesla must have been aware of the inverse square law because Maxwell's equations had already been published. But you were also noting how he was more of an artist than a tinkerer. So when thinking about things like, I'm going to transmit to the entire Earth, was he thinking about that, or did he just think he could, think his way beyond it?
Right. Okay. Absolutely spot on question. Okay. He didn't believe that the inverse square law applied to the propagation of the waves that he was generating. Okay. Now, his big idea was he was going to set up in the Earth, if you're at Colorado Springs, stationary waves. Okay, in other words, you'd hit the resonant frequency of the Earth, and this room is perfect. If you I can see it. I apologize if you have to turn around and back. But he imagined that there would be a wave traveling through the Earth, much like the way the lighting is on that wall. Okay, if he figured I set up this stationary wave, right, there are minimal energy losses as the energy moves through the crust of the Earth. So he thought that the inverse square law didn't apply in his situation. Obviously, it does. And that was one of the problems. This was a guy that, Tesla was an individual who actually worked out all of this stuff. He thought that what he was observing in electromagnetic waves was not transverse waves, again, like you see, or which is approximated by the lights on the wall, but he was actually thought that you had the waves that were longitudinal waves like you have in a slinky. In other words, they're like sound waves. And Tesla was so sure of this that he actually went to HERTZ and visited him and told HERTZ that HERTZ was wrong. Now, where this gets really deep and complicated, and I'm about to basically put on my water wings to say this, is if you get into a big discussion with people about electromagnetic propagation, they will tell you that Maxwell's equations, some will tell you that Maxwell's equations predict that there are two parts to the propagation. There is the transverse wave, which is what we think about most of the time, but there is also a scalar wave that goes with it. Okay? And depending on who you talk to, some people would say that Tesla had it right, that more of the electromagnetic propagation phenomena is about scalar waves and not electromagnetic waves. Sadly, these people then immediately go off onto this sort of conspiracy thing, which is once again that RCA and Marconi and other people have basically suppressed the truth about scalar waves. Now, every time I want to know from my electrical engineer, I'm a professor in an engineering school. Every time I want to know about the scalar dimension of electromagnetic propagation, I go see my friends in the electrical engineering department. They kind of look at me like, I don't know, dude. We're talking like, we're talking serious electrical engineering theology. I don't know whether we're going to actually talk to you about this. So it is, there may be something to this, but it is beyond the scope of what I understand. But you hit it spot on, and I appreciate you bringing up the inverse square law. Tesla did not believe the inverse square law applied to him. Great. All righty. Let me turn it around and say to you, I think this is a guy that talks about the information revolution. This is somebody who's talking about the information revolution in ways that your Google is acting on day in, day out. This notion that information should be broadly available to lots and lots of people, and how are you going to deliver it in ways that are good for the people, but also profitable for the company. I mean, does this resonate with you folks, or am I saying something that's like, dude, it's like the water we swim in. Nothing really to say about it. So, but I kind of want to stick him in there that that he's about a different sort of story about how electrical and electronic technologies are going to change our lives. He's not an Edison character, and there's reasons why he's often thrown into contrast with Edison because Tesla had a very different social vision than Edison. So, but you all have day jobs to go to. I'm doing my day job, so as a teacher. So thank you very much. Thanks for coming out. I'm happy to sign some books.